China just built a solid-state battery with 1,000 kilometers of range. You heard that right, 620 miles on a single charge, which means you could drive from New York to Florida without stopping once to recharge. That's the equivalent of driving across an entire country without a single worry about your battery dying. And they didn't just build a prototype in some lab. They're claiming they can actually manufacture this at scale. But here's what makes this announcement so earth-shaking. If China actually pulls this off, they just rewrote the entire rulebook for how the world drives. Every assumption about electric vehicles just became obsolete. Every advantage that traditional automakers thought they had just evaporated. And the power balance of the global auto industry is about to shift in ways that nobody saw coming. Let's start with understanding what we're actually dealing with here, because the current battery technology powering your EV is already hitting a wall. The lithium-ion ceiling. You're driving an electric car right now, maybe a Tesla, maybe a Chevy Bolt, maybe something else. But no matter what brand you're behind the wheel of, you're dealing with the same fundamental limitation that every EV on the planet faces: lithium-ion batteries. These batteries have been the backbone of the electric vehicle revolution for the past 15 years. They're reliable, they're reasonably efficient, and they've made electric cars viable for mainstream consumers. But they're also hitting a wall. The problem starts with what's inside the battery itself. Traditional lithium-ion cells use a flammable liquid electrolyte, basically liquid fuel, to move ions between the positive and negative terminals. This liquid design has worked well enough to power your phone, your laptop, and your car. But it comes with inherent limitations that engineers have been banging their heads against for years. The energy density has plateaued. You can squeeze more power out of a lithium-ion battery, but the returns are diminishing. You're hitting physics walls that can't be broken with incremental improvements. And then there's the safety issue that nobody likes to talk about. That flammable liquid electrolyte, it's actually flammable. EV fires happen. They're rare, but they happen. And when they do, they're catastrophic. A lithium-ion battery fire doesn't just burn, it explodes. The thermal runaway effect can destroy an entire vehicle in minutes. Tesla has had recalls. Other manufacturers have had recalls. The industry has learned to manage the risk, but the risk is always there, lurking beneath the surface of every electric vehicle on the road. Then came range anxiety. Yes, modern EVs can go 200 to 300 miles on a charge, which is fine for daily commuting. But that doesn't eliminate the fundamental problem. You need to plan your road trips around charging stations. You need to stop for 30 minutes to an hour to recharge. You need to find a charger that actually works, because charging infrastructure is still spotty in most of the country. And even after you charge, you're sitting there waiting. This is the invisible ceiling that's been holding back EV adoption. No matter how good the cars got, no matter how affordable they became, range anxiety remained the one thing that kept people clinging to gas-powered vehicles. Engineers around the world knew the solution existed. They knew that if you could replace that flammable liquid electrolyte with a solid material, you could increase energy density dramatically. You could make batteries safer. You could make them charge faster. You could make them last longer. The physics was clear. The chemistry was sound. But manufacturing solid-state batteries at scale, that was a different problem entirely. That was a nightmare that nobody had solved. For years, the biggest battery manufacturers in the world, companies in Japan, South Korea, Germany, and the United States, were working on solid-state technology. They were making progress in labs. They were producing prototypes, but commercialization felt years away. Experts were saying 2030 and beyond before solid-state batteries would actually be available in consumer vehicles. The consensus was clear. This technology was still a decade away. Then China made an announcement that nobody expected. China's impossible claim. You need to understand how shocking this announcement actually was. Western battery manufacturers had spent over a decade developing solid-state technology in relative secrecy. They were protecting their intellectual property, moving methodically, treating this like the holy grail of battery technology. And then, out of nowhere, China announced they'd already done it. Not only had they developed it, they were claiming they could manufacture it at scale. They were claiming 1,000 kilometers of range. They were claiming faster charging, longer lifespan, and inherent safety advantages. And they were claiming they could do it soon. The immediate reaction from Western companies was skeptical. Some said it was impossible. Some said it was vaporware, an announcement designed to manipulate stock prices and influence investor sentiment. Some said the Chinese were exaggerating or outright lying about their capabilities. But then the technical details started coming out, and the skepticism turned into something closer to panic. Which Chinese company made the breakthrough? That's where it gets interesting. CATL, Contemporary Amperex Technology, is the world's largest EV battery manufacturer. They're absolutely dominating the global battery market, and they announced they had solid-state technology ready for production. But it wasn't just CATL. BYD, another Chinese battery giant, was also making moves into solid-state. And behind them, Chinese research institutions were publishing papers showing they'd cracked problems that Western scientists had been struggling with for years. How did they do it? The answer involves state investment, focused research, and something that Western companies don't have: the ability to move resources at massive scale without worrying about quarterly earnings reports or shareholder pressure. The Chinese government identified battery technology as a national priority. They poured billions into research. They coordinated between companies and universities in ways that would violate antitrust laws in the United States. And they moved faster than anyone thought possible. But here's where it gets tense. There's a massive difference between claiming you can manufacture solid-state batteries and actually doing it at scale. Lab breakthroughs don't automatically translate to mass production. There are manufacturing challenges that are exponentially harder than the chemistry. There are cost barriers that could make these batteries too expensive to put in vehicles. There are supply chain questions that nobody's answered yet. Western skeptics were quick to point this out. Sure, China might have developed the technology, but can they actually manufacture it? Then came the most shocking part of all. Chinese companies started revealing their timelines. Not 2030, not 5 years away. They were talking about vehicles hitting the market in the next 18 to 24 months. They weren't talking about limited production runs. They were talking about scaling up to millions of units. They were talking about making this technology affordable. They were talking about doing something that the entire Western battery industry had said was impossible. And it wasn't just talk. They started showing prototypes. They started demonstrating real vehicles with solid-state batteries. The skepticism that had characterized the Western response began to crack. Then came the most devastating realization of all: why this changes everything. You need to understand what 1,000 kilometers of range actually means for the electric vehicle industry. It's not just a number, it's a threshold. It's the moment when every argument against electric vehicles becomes irrelevant. It's the moment when the last legitimate excuse people have for driving gas-powered cars disappears. Think about your daily driving. Unless you're crossing an entire continent, you probably drive less than 300 miles per day. 1,000 kilometers is 620 miles. You could drive for 2 full days, actual driving time, not stopping, before you'd need to charge. You could drive from Los Angeles to San Francisco and back without charging once. You could drive from New York to Boston and still have half a tank. For the vast majority of human driving patterns, 1,000 kilometers of range is effectively infinite. But the real shock comes when you think about road trips. Suddenly, charging infrastructure becomes irrelevant. You don't need to plan your route around charging stations. You don't need to add hours to your trip sitting at a supercharger. You can drive from coast to coast with maybe 1 or 2 charging stops, just like you would in a gas-powered car. The entire infrastructure limitation that's been holding back EV adoption just vanished. And then there's the cost equation. With 1,000 kilometers of range, the math changes completely. You're no longer paying a premium for an electric vehicle. You're getting a vehicle that goes further than most gas cars, charges faster than you can pump gas, costs less to operate, and lasts longer. The total cost of ownership swings dramatically in favor of electric. The financial incentive to buy a gas-powered car disappears. But this creates a cascading problem for the Western auto industry. Tesla, which has dominated the EV market through superior technology and range, suddenly finds that technology advantage eroding. Traditional automakers, who were already struggling to compete with Tesla on performance and range, now face an existential crisis. They've been betting that they could catch up gradually, that they had time to transition from gas to electric. 1,000-kilometer solid-state batteries just collapsed that timeline. They don't have time anymore. They need to transition now, or they'll be left behind. And here's where the tension really sets in. The companies that control solid-state battery manufacturing will control the future of the auto industry. It's that simple. If China owns this technology, China controls which automakers can build competitive vehicles. China controls who gets batteries and who doesn't. China controls the supply chain that determines which countries' auto industries thrive and which ones die. This isn't just about battery innovation. This is about geopolitical power. The manufacturing nightmare. But here's where reality gets messy. Announcing solid-state batteries is one thing. Actually manufacturing them at scale is a completely different nightmare. You need to understand just how hard this actually is. Building a lithium-ion battery is already complicated. You need precision manufacturing, quality control, consistency in materials. But lithium-ion is mature technology. Engineers have spent 15 years optimizing it. They've built factories that can produce millions of batteries per year with acceptable defect rates. Solid-state batteries? They're a completely different beast. Solid materials are fragile. They're difficult to work with. They don't flow the way liquid electrolytes flow. You can't just adjust your manufacturing process from liquid to solid. It's like asking a baker to switch from water to concrete and expecting the same oven to work. Everything changes. The temperatures need to be different. The pressures need to be different. The layer thicknesses need to be more precise. 1 micron of variation can destroy an entire batch. And then there's the dendrite problem. When ions move through solid materials, they can create crystalline growths called dendrites. These growths can short-circuit the battery, causing it to fail or catch fire. It's a manufacturing problem that Western engineers have been struggling to solve for years. China claims they've solved it. But solving it in a lab is different from solving it in a factory, producing millions of batteries per year. There's also the raw material question. Solid-state batteries use different materials than lithium-ion, sometimes ceramic compounds, sometimes polymers, sometimes hybrid materials. These materials need to come from somewhere. Supply chains need to be established. Mining needs to happen. Processing plants need to be built. This isn't something you can do overnight. And if China controls the supply of these materials, they control the entire industry again. Then came the cost problem that nobody wants to discuss publicly. Solid-state batteries are exponentially more expensive to manufacture than lithium-ion batteries right now. We're talking about batteries that cost 3 to 5 times as much to produce. That might be acceptable for a premium vehicle, but it completely changes the economics of mass-market EVs. For solid-state batteries to transform the industry, manufacturing costs need to drop dramatically, and nobody's publicly explained how China plans to achieve that. But perhaps the biggest question is timing. Even if China can manufacture solid-state batteries today, scaling up from pilot production to millions of units per year is a Herculean task. It takes years to build factories, train workers, establish supply chains, and work out manufacturing problems. Yet China is claiming they'll have vehicles on the market within 18 to 24 months. Either they're being wildly optimistic, or they've already solved problems that Western engineers thought were years away from solution. The Western auto industry is watching very carefully, because if China actually pulls this off, everything changes. The global market earthquake. Imagine you're a traditional automaker. You're General Motors, or Ford, or Volkswagen, or BMW. You've been making cars for over 100 years. You survived the transition from horses to cars. You survived economic depressions and world wars. But now you're facing something that might actually be able to kill you. The end of the internal combustion engine happening faster than you can adapt. You were counting on having at least another decade to transition to electric vehicles. You were counting on gradual change, on incremental improvements, on having time to retool factories and develop new supply chains. You were counting on range limitations, keeping gas-powered vehicles competitive. And then China announced 1,000-kilometer batteries, and all of those plans became obsolete overnight. If 1,000-kilometer solid-state batteries hit the market at competitive prices, the entire value proposition of gas-powered vehicles collapses. There's no reason to buy a gas car anymore. You're paying more upfront, you're paying more for fuel, you're paying more for maintenance, and you're getting less range. The math doesn't work. The emotional arguments don't work. The only advantage that remains is refueling infrastructure, and that advantage disappears if you never need to refuel because your range is effectively infinite. This triggers a price war. Automakers that can source solid-state batteries can suddenly offer vehicles with superior range, superior performance, and potentially superior cost of ownership. Automakers that can't source these batteries will see their EV sales collapse. And since China controls the supply of solid-state batteries, China controls who wins and who loses. Tesla's position becomes precarious. Tesla has dominated the EV market through superior range and performance. But if every automaker suddenly has access to batteries with 1,000 kilometers of range, Tesla's competitive advantage evaporates. They still have brand loyalty and software advantages, but the raw technology edge that made them unstoppable is gone. And Tesla doesn't make their own batteries. They rely on suppliers. If CATL and BYD won't sell batteries to Tesla, Tesla's future becomes questionable very quickly. Traditional automakers face an even worse situation. They're years behind on EV development. Their software is inferior. Their supply chains aren't established. Their factories aren't ready. But now they're facing an enemy that doesn't just have better technology, they have better batteries. And those batteries are made by Chinese companies that have no incentive to help Western automakers compete. But the economic impact goes even deeper than that. The auto industry is one of the largest industries in the world. Millions of people work in auto manufacturing, auto sales, auto service, auto parts supply. If the auto industry shifts to Chinese-made batteries, entire supply chains get disrupted, jobs disappear. Entire regions dependent on auto manufacturing get devastated. The geopolitical implications are staggering, and it's not just about cars. The power shift nobody's talking about. Here's what makes this announcement actually terrifying. It's not about batteries, it's about power. And not electrical power, geopolitical power. For over a century, the auto industry was the cornerstone of Western economic dominance. America made cars, Europe made cars, Japan made cars. These countries dominated the global market, controlled the supply chains, employed millions of workers, generated enormous tax revenue. The auto industry was one of the primary reasons that Western nations maintained economic and geopolitical supremacy. Electric vehicles were supposed to preserve that dominance. Yes, China was getting into EVs. Yes, China was building batteries. But Western companies had brand recognition, technological expertise, manufacturing experience. The assumption was that even if China built batteries, Western automakers would still dominate the industry. Electric vehicles would just be a new version of the old game. But solid-state batteries changed the equation. Battery technology is the constraint. Whoever controls the best batteries controls the industry. And China just demonstrated that they control the best batteries. This isn't speculation anymore. This isn't projection. This is actual demonstrated capability. Think about the implications. If China controls solid-state battery manufacturing, China controls which automakers can build competitive vehicles. A Western automaker that can't source solid-state batteries is essentially dead. A Chinese automaker with access to unlimited batteries from CATL and BYD has an insurmountable advantage. The global auto industry doesn't gradually shift toward Chinese dominance, it flips overnight. This isn't just about market share. This is about strategic leverage. Electric vehicles are going to power human transportation for the next century. The company that controls EV batteries controls transportation. The country that controls EV battery manufacturing controls energy, supply chains, and geopolitical influence across the entire planet. This is why China's government made battery technology a national priority. This is why they invested billions. This is why they coordinated between companies and universities in ways that Western competitors couldn't match. And here's the part that keeps Western strategists awake at night. They saw this coming. The battery industry experts knew this was the future, but they were too slow, too cautious, too constrained by quarterly earnings reports and shareholder pressure. By the time Western companies understood the stakes, China had already won the race. You started this video thinking you were learning about car batteries. But what you're actually watching is the moment when the global balance of power in one of the world's largest industries shifted toward China. The moment everything changed. You started this video thinking you were learning about car batteries. But what you're actually watching is the moment when the global balance of power shifted. Not gradually, not over decades, right now. This is the inflection point. For over a century, Western nations controlled the auto industry. America made cars, Europe refined them, Japan perfected them. This wasn't just about manufacturing, it was about power. It was about jobs, tax revenue, geopolitical leverage, and the ability to shape the future of human transportation. Electric vehicles were supposed to preserve that dominance. Western companies had the brands, the expertise, the infrastructure. China was just a competitor, not a threat. But solid-state batteries changed everything. Battery technology is the constraint. Whoever controls the best batteries controls the entire industry, and China just demonstrated they control the best batteries. This isn't speculation. This isn't projection. This is demonstrated capability backed by actual prototypes and announced timelines. Think about what happens next. If solid-state batteries hit the market within the next 18 to 24 months, every Western automaker faces an existential crisis. You can't build a competitive EV without access to batteries with 1,000 kilometers of range. You can't compete with Chinese automakers who have unlimited access to CATL and BYD batteries. You can't retool your factories fast enough. You can't build new supply chains overnight. You're finished before you even realize the game has changed. This isn't hyperbole. This is the death of Western auto industry dominance playing out in real time. Tesla's competitive advantage disappears. Traditional automakers that spent over a century perfecting internal combustion engines suddenly find that expertise is worthless. Entire regions built on auto manufacturing become economically devastated. Millions of jobs vanish. Tax bases collapse. And China doesn't just win the EV market. China wins transportation itself. But the real horror is that Western strategists saw this coming. Battery industry experts understood the stakes. They knew solid-state technology was the future. They knew whoever controlled it would control the industry, but they moved too slowly, too cautious, too constrained by quarterly earnings and shareholder pressure. By the time the Western auto industry understood what was happening, China had already won. This is why China's government made battery technology a national priority. This is why they invested billions into research. This is why they coordinated between companies and universities in ways that Western competitors couldn't match. While Western companies were protecting intellectual property and moving cautiously, China was sprinting toward the finish line. You're watching the moment when a trillion-dollar industry shifted from Western to Chinese control. You're watching the moment when geopolitical power realigned based on battery chemistry and manufacturing capability. You're watching the moment when 1,000 kilometers of range didn't just revolutionize transportation, it rewrote the rules of global economic dominance. China didn't just build a solid-state battery with 1,000 kilometers of range. China just built the future. And they built it while the rest of the world was still arguing about whether it was possible.